Good morning to all. I am Dr.B.Angelin, Assistant Professor, Department of Information Technology, working in Dr. S.N.S. Rajalakshmi College of Arts and Science. Now I am going to discuss about the deadlocks and starvation in operating system. Deadlock and starvation. Deadlock occurs when none of the processes in the set are able to move ahead due to the occupancy of the requirement resources by some other process. Starvation in operating system occurs when a process waits for an indefinite time to get the resource it requires. Deadlock is a process design, its distributed design issues. Starvation is a problem of resource management where in the operating system the process does not have resources because it is being used by other processes. It is a problem when the low priority process gets jammed for a long duration of time because of high priority requests being executed. Then we examined the three common approaches to dealing with deadlock: prevention, detection and avoidance. We look at one of the classic problems used in illustrate both synchronization and deadlock issues, the dining philosopher problems. In the context of operating system, starvation refers to a situation where a process or a resources is unable to make progress or access a particular resources it needs due to the allocations of resource to other processes or tasks. Deadlock, livelock and starvation. Livelock is a deadlock-like situation in which processes block each other with a repeated state change yet make no progress. Starvation is the outcome of deadlock, livelock or as a result of continuous resource denial to a process. Conditions of deadlock. A deadlock is operating system is a situation in which more than one process is blocked because it is holding a resource and also requires some resource that is acquired by some other process. The four necessary conditions for a deadlock situations are mutual exclusion, preemption, hold and wait and circular set. What is a deadlock starvation? Starvation occurs when one or more threads in your programs are blocked from gaining access to resource and as a result cannot make progresses. Deadlock, the ultimate form of starvation. It occurs when two or more threads are waiting on a condition that cannot be satisfied. The process of deadlock starvation. Deadlock occurs when none of the processes in the set are able to move ahead due to the occupancy of the required resources by some other process. Starvation in operating system occurs when a process waits for an indefinite time to get the resource it requires. Deadlock is a process design distributor design issues. Starvation problem. Starvation is the problem that occurs when low priority processes get jammed for an unspecified time as the high priority processes keep executing. A steady stream of higher priority methods will stop a low priority process from ever obtaining the processes. Real life example for deadlock. Another real world example of deadlock is the use of a single track by multiple trains. It says a multiple tracks coverage onto one. There is a train on each individual track leading to the one track. All the trains are stopped waiting for another to go through, none of them move. How prevent deadlock? Strategies such as a resource allocation, denial resource ordering, hold and wait preventions, preemptive resource allocations and spooling input-output scheduling. It's contribute to preventing deadlocks by breaking one or more of the necessary conditions for deadlock informations. Starvation in multi-threading. Starvation describes a situation where a thread is unable to gain regular access to shared resources and is unable to make a progress. This happens when shared resources are made unavailable for long periods by greedy threads. These are the starvation is multi-threading. Starvation deadlock is in a situation when all processes are holding one resources each while they wait for another process to acquire different resources. Algorithm for starvation is priority scheduling algorithm. Thank you.